Okay, we're going to talk about ionic compounds first. So before we can talk about the compounds themselves, we have to talk a little bit about the individual ions. So there are ions that have predictable charges. So these are metals that are in groups 1A, 2A, and 3A. Okay, 1, 2, 3. Those are the numbers on the columns that have the A's. So groups 1A, 2A, 3A. All of the metals in group 1A form +1 ions. All the metals in group 2A form +2. And all the metals in group 3A form +3 ions. That's convenient, huh? This is why I like those numbers instead of the other numbers. And then there's two that are just kind of random that you have to memorize, zinc and silver. So you'll hear me chant this a lot, groups 1A, 2A, 3A, zinc and silver. These are the elements that have predictable charges. The nonmetals, these guys are all metals. Metals form positive ions, nonmetals form negative ions. The nonmetals are also predictable. One way you can figure out their charge is to look at their group number and subtract 8. Or what most students prefer is just count backwards, count negative from group 8A. So if it's in group 7, like fluorine, you start at neon, you go -1. There you go, it's -1. The group number is 7. If you subtract 8, you get -1. So important to understand, ionic compounds always have a positive and a negative ion. Opposite charges attract each other, like charges repel each other. So you can't have a compound with two positively charged ions. They're not going to stick together. They're going to fly apart from each other. And in the chemical formula, the sum of the positive charges has to equal the sum of the negative charges. Overall, an ionic compound is neutral. There are enough positive charges to completely and perfectly balance the negative charges. So when we're writing formulas for ionic compounds, we write the symbols for both charges first. This is kind of like the little showing your work part. Do not skip this until you get good at it. The first thing you need to do is you need to write the symbol for each of the ions, and you need to include the charges. We have to look at the charges because the charges tell us how many of each go together. Then what you need to do is you need to make the magnitude of the charge on each ion become the subscript for the other ion. This is called the crisscross method. It's not the only way, but it's the one that makes sense to the most students. I'll be telling you another one in lab, but probably not today. And we often refer to this as crisscross. And then you need to look at your subscripts, and sometimes you need to reduce them. So this is a little bit like having a fraction that's 4 to 2. That can be reduced to 2 to 1. Ionic compound formulas are always the lowest ratios. And then you have to double check and make sure that your charges are going to all add up to 0. So let's do some examples. Write a formula for the compound that forms from strontium and chlorine. Okay, strontium is Sr. It's over on the left side of the periodic table. It's a metal, so this is going to be an ionic compound. So the first thing we need to do is write the formulas for each of these ions. So strontium is Sr. And what is the charge on a strontium ion? It's 2+, because strontium is in group 2A, and all of those guys have 2+ charges. So we have strontium 2+, and chlorine has the symbol Cl. I like to make a script L because, what is that? Is that a 1, a lowercase l, or a capital I? Could be any of them, right? Chlorine is in group 7A. So what's the charge on a chlorine ion? -1. So I'll put the negative, I don't write the 1 though. So what we're trying to do here is we're trying to figure out how many of these are going to get with how many of those so that their charges add up to 0. So the crisscross method is taking the number and making it be the subscript for the opposite element. Here the number is an unwritten 1, and that becomes an unwritten 1 on the strontium, and we end up with SrCl2. So I took this 2, that came down to be the subscript on the chlorine. The unwritten 1 comes down to be the subscript, an unwritten 1 on the strontium. So let's see how this makes the charges work out. So SrCl2 means I have 1 strontium ion and 2 chloride ions, right? So I have a total of +2 charge from that 1 strontium ion, and with these 2 chloride ions, that doesn't look very good. I'm going to fix that. Looks like some weird new letter I invented. 2 chloride ions, that's going to be a total of -2 charge. +2 plus -2 equals 0. Any questions? Let's do one for the compound that forms between aluminum and nitrogen. Well, aluminum is a metal. We need the formula for aluminum. The symbol is Al, and we need to know the charge. What group is it in? It's in group 3A. If it's in group 1A, 2A, 3A, zinc or silver, then we can figure out the charge. So aluminum is in group 3A, it's a 3+ charge. And then nitrogen is N. What group is nitrogen in? It's in group 5A, right? So you can count back on the periodic table from neon, -1, -2, -3, or you can take group 5A and subtract 8, you get -3. So this is a 3- charge. So if I crisscross these, what am I going to end up with? Al3 and 3. Well, could that be reduced 3 to 3? Yeah, I could. We should reduce that to AlN. So one way you can avoid having to reduce things like that, before you crisscross, look at the charges. Here we have +3 and -3. We don't really need to crisscross. We just need one of each of them. If the numbers are not the same, if this is 3 and this is 2, then we should crisscross. Or if this is 3 and that's 1. But if the numbers are the same, you can just push those two guys together and their charges will add up to 0. If you prefer to crisscross and simplify, that works also. But this is the correct answer, AlN. Now, you need to be careful when you're writing these formulas. I know that some people like to use small capitals and large capitals. Don't do that on your chemical formulas. You can do that in all the rest of your writing. But like for aluminum, I don't want to see this. Because that's an uppercase, a capital L, and that's not cool. It needs to be a lowercase l, so that's not okay. Polyatomic ions. Do any of these guys look familiar? They should be. I made you memorize some of them for the memorization quiz. So pull those flashcards out if you need to. Polyatomic ions are groups of atoms that have an overall charge. And these are the ones that we put parentheses around. The names of these and their formulas need to be either memorized or looked up in a table. And what I would encourage you to do as you're doing homework and studying and doing labs and stuff is try to do it from memory first and then look it up, because you'll learn it more that way. So they all have very specific names, and some of these names are very similar. We've got nitrate and nitrite. The difference is one letter, and in the formula the difference is one number. This is NO3 with a -1 charge, and this is NO2 with a -1 charge. And I know some of you are not fans of details, but there are times when details matter, and this is where details matter. So this is a table from your book. So if we're going to use a polyatomic ion, let's do this example. Formula for the compound that forms between calcium and nitrate ions. Well, calcium is a metal. What group is calcium in on the periodic table? Group 2. So it has a 2+ charge. And then nitrate, we have to memorize that one. You should have memorized it. NO3 with a -1 charge. There's no real reasoning that out. You just have to memorize it. It's like, why is this the letter C? Because, right? And how do you know that? Well, you memorize it. So if we're going to put these together, we're going to need 2 of these. So some of you can see that you just do some little math in your head, and others of you are, we're looking for a lowest common multiple. That's great. Or you can crisscross. We're going to look at this. This is 2 and 1. They're not the same, so this would be a good situation to crisscross. So we're going to get calcium with a subscript of 1 that we don't write, and nitrate needs a subscript of 3. This is a polyatomic ion. If we have more than 1, we need to put parentheses around it. So I'm going to have 2 of these, so I'm going to put parentheses. I'm shrink wrapping it, and then I put a 2 on the outside. I have 2 of those units, because I don't want it to look like 32 oxygens. That would be silly. Any questions? Let's look at aluminum and phosphate ion. I just kind of hung up on aluminum. Well, what's the charge on aluminum ion? 3+. And remember the formula for phosphate ion? PO4 with a -3 charge. So we have +3 and -3. Do we need to crisscross? No. We just need 1 of each. So we're going to have Al PO4. That reminds me of dog food. Alpo. Pardon me? Aleppo? Oh. I heard a reference to that, but I didn't hear enough to actually get it. But yeah, that's similar. Why didn't I put parentheses around the PO4? I don't need them. I only have 1. And sometimes that bothers students. It's like, well, why can't I just put parentheses around all the polyatomic ions? Well, it's extra stuff. We're trying to be concise and efficient, and so if we don't need the parentheses, we don't write the parentheses. How about sodium and sulfite ions? Well, what's the symbol for sodium? Na. And what group is it in? It's in group 1A, so it has a +1 charge. Sulfite. I didn't make you memorize that one. That's SO3 with a 2- charge. Do I need to crisscross with these charges? Yeah. So this unwritten 1 becomes the subscript for the sulfite, and the 2 becomes the subscript for the sodium, and I get Na2SO3. And again, I don't need parentheses because there's only 1 sulfite. Yes? We don't write the charges in the chemical formula. So you need to write the charges here until you get really good at this, which may or may not happen this semester. It's okay. You need to look at the charges here so that you can tell how many of each of them you need. And so I want you to write these down. We don't write the charges in the formula because that would make things really messy. So then we have Na2 plus SO4, not 4, 3, 2 minus. It just gets very, very messy and confusing. So we leave the charges off. So do not write charges in an ionic formula for the whole compound. It's a good point.